started. So, once again, good evening to everyone. I hope you are all doing wonderfully well. Welcome to our second collab session. So, today I will be taking you through the calculations that you see up on the screen. This is based on the third learning unit. So that is learning unit 3, descriptive statistics. So I'll go through as many as I possibly can. And then again, as I had done with learning unit 2, I will let you know once I have made a recording available covering whatever I didn't get to complete in this session. So I'm hoping you have been able to listen in on the previous live collab session, which was the intro to stats, and we had started with learning unit 2 as well. And then I also uploaded another video for you. It's just a pre-recorded session that I had done with another class, and it covers pretty much everything for learning unit 2. So let's go ahead and continue with what we are looking at today. This is Learning Unit 3. As I said, it is a section called Descriptive Statistics, and it's all about calculating your various measures such as your mean, your median, your mode, your quartiles, your percentiles, your variance, and so on. So let's go ahead and get started. As you can see, there is a heading specific to the first set of calculations that we're looking at, and this is called ungrouped data. It is important that you are aware of the difference between grouped and ungrouped data. So if you look at ungrouped data, as you can see, the values are randomly listed out for you. They are single individual values that are listed out for you. And grouped data is different from this in the sense that, as you can see here, in this first column, instead of just having randomly listed out values, you have intervals. So the first one is from 10 till 30, then 30 to 50, 50 to 70, and so on. So instead of just having randomly listed out figures, we here have categories or classes of information, and we then would have to naturally go about these calculations a little differently. So let's go ahead and get started with this page. So this is your ungrouped data. And here it says to you that the following data set indicates the number of trips that a person makes to the local store over a period of 10 years. So that's quite important, that opening statement, because they say to you here that it's over a period of 10 years, which means that you have 10 numbers given to you in this data set, and that makes your sample size equal to 10. So I'm going to write that on the side here because we do need to know what your sample size is. And the sample size is denoted by the letter N, which in this case, as we said, is 10. So the first calculation asks you for your mean, then you have your median, your mode, your quartiles, and so on. You actually don't need to worry about number 4 too much, but I will go through it anyway. And then you have a host of other calculations. So let's look at what the first step generally is. So a lot of the time, although you don't need it for every calculation, the best way to start with a section like this is to rearrange your values so that they are in ascending order, meaning from smallest to largest. So I'm going to rearrange these figures and write it out for you in ascending order so that when we do require it in ascending order, it already is done for us and we can just look to the information and get to our solutions. So the first value was 41, then 88, 97, 109, 127, 142, excuse me, 142, 144, 165. Sorry, let me just move this a bit to the side here and then continue there. So 165, 183, and 199. Okay, so we've now rearranged that. It makes it quite easy for us when we need our median, our first quartile, our third quartile, and so on. So the first calculation is the mean. The formula for the mean is that we will add up all of the values. It is referred to as the sum of x. So it's the sum of x over n. We know that n is our sample size, which is 10. The sum of x means we're simply adding up all of these values and dividing them by however many there are. So when we sum up all of these values, 165 plus 97 plus 142 plus 109 plus 127 and so on, once we've added up all of those, that gives us a sum of 1,295. So that becomes your numerator in the calculation, and that is then divided by n, which is 10, which gives us 129.5. So that's the first calculation done. That's your mean. Then you have your median. So your median, first step is generally to rearrange your values, which in this case is already done at the top, so we don't need to do that. But generally, if you haven't already done it at the top, the first step will be to rearrange your values in ascending order. The second step is to determine the position of your median. So when it comes to ungrouped data, because remember this is the section we're looking at, ungrouped data first, the formula for the position is n plus 1 divided by 2. So n in this case is the 10 that we had made note of at the beginning. 10 plus 1, which is 11, divided by 2 tells us that the position is the 5.5th value. This is only the position. This is not the actual value of the median. So we do need to do a bit more work after we now know what the position of the median is. So to get to the actual median, we are going to look at the position. It said to us it's the 5.5th value in the data set. This means we're going to take the fifth value, and I'm just going to do it here to show you what I mean. Because it's between the fifth and the sixth value, the 5.5th value, you're going to take the fifth value and the sixth value, and you're going to add them and divide them by 2. So this is why we need the values to be in ascending order, because we need to identify which is the fifth value and which is the sixth value. So if you look at this, the fifth value, your count, this is the first, second, third, fourth, fifth, sixth. So the fifth and sixth value is 127 plus 142, and that's divided by 2. Value is 127 plus 142, and that's divided by 2, which then gives you an answer of 134.5. And that is then your median. So I'm going to erase here and just write down the final answer, so that we have some space to work, and we also are keeping track of what the values have been so far. So 129.5 is your mean. Your median is now 134.5. So we're done with your mean, we're done with your median. Then you have your mode. Now, your mode is the most frequently occurring value in a data set. And if you look at this data set, there's actually no number that's repeated. So if you find that there are no numbers that are repeated in a data set, then all you have to do is simply state that there is no mode. So you're just going to write down, like I am here, that there is no mode. So that's question 3. It's as simple as that. If you find that there is no number that's repeated, there is no number appearing more than once, then all you have to do is state that there is no mode. Then the next question says to you to comment on the skewness of the distribution. Now, this is something that's very rarely asked, and the reason it's not commonly asked is because to determine skewness, there generally is a formula that will be used. It's actually the last question here at the bottom, number 14. So previously, you could have just looked at the mean, median, and mode and commented on the skewness of a distribution. But because there is a formula that can be used, a statistical formula or measure that can be used, we just use that measure or calculation to determine the skewness. However, just for the purpose of, in case it comes out, so just for the purpose of being prepared, we will look at how to comment on the skewness by looking at the mean, median, and mode. So the mean, median, and mode. If you had a situation where the mean is greater than the median and that's greater than the mode, then this would say to you it is a positively skewed data set. If it is the opposite, where the median is actually the mean is actually the smallest value, so the mean is less than the median, which is less than the mode, then that's a negatively skewed data set. And if you find that they are all equal to each other, so the mean is equal to the median and that's equal to the mode, then that's going to be a symmetrical distribution. Okay, so here, if you look at this example, since there is no mode, you don't have to worry about the mode in this statement. So ignore that, the mode here and here and here, and just work with the mean and the median. So if you find that exactly as you'll read it on the screen, if the mean is greater than the median, then it will be a positively skewed distribution. If the mean is less than the median, then it will be negatively skewed. And if the mean is equal to the median, then it will be a symmetrical distribution. So from the information that we have, as you can see, the mean is 129.5 and the median is 134.5. So the mean is actually less than the median. And that is the second one here, which says to us that it is a negatively skewed distribution. So you would then write down that this is a negatively skewed distribution or negatively skewed data set. Okay, so that's the first 4 then complete. Let's look at number 5. Okay, so number 5 asks you to calculate the first quartile. Now, the first quartile is calculated or carried out in a very similar way to your median calculation. So I just want to erase at the bottom here. Sorry, just give me a second. I just need some space. So as I was saying, your median is the 3 steps that I had written out on the side here. So I'm just going to erase this as well and leave what was necessary for that question. So you knew it was negatively skewed. Okay, so back to what I was saying. Your first quartile and your median follows the exact same three steps. So the first step is, and it's here, to rearrange your values in ascending order, which is already done. The second step is to determine the position. The third step is to actually calculate the value. In this example that I had done, it was the median, but in the question we're currently working with, it is the first quartile. So as I said, the steps are exactly the same. Now here, step one is already done. We don't need to rearrange the values. So that's taken care of. We can tick that off. Step two is to determine the position of your first quartile. So remember, the quartile, literal to the word, is looking at spreading your data set into 4 equal parts. You're basically spreading your data set into quarters. And sorry, just erasing that. And I'm just going to draw this up for you to be able to visualize what I mean. If this is your number line, then your Q1 is here, your Q2 is here, your Q3 is here, and then your Q4. So Q4 should be somewhere here. So it split your data set into 4 equal parts. This is the first 25%. This is the next 25%, which in total gives you half of your data set. You add on the next 25%, it gives you 3/4 of your data set. And then you have the last quarter, which gives you 100% of your data set. So data set, and then you have the last quarter, which gives you 100% of your data set. So we only actually calculate Q1 and Q3 as the quartiles. You'll never need Q4. And Q2 is the same as the median. Q2 is also known as the median. So that we've done already. So now we're looking at calculating Q1 and Q3. In order to calculate it, as we said, it's exactly the same steps as you would follow with your median. So we rearrange the values. We now need to determine the position. And under ungrouped data, the position is calculated as n+1 over 4. This is for your quartile, your first quartile. Then it's 10 plus 1, which is 11 over 4. And that tells you that the position of your first quartile is the 2.75th value. And again here, this is looking at a decimal like we saw with your median. So there's a bit more work that needs to be done before we get to the actual value for your quartile. Now here it's a little bit different to the median. Here, because it's 0.75, what you're going to do is draw a line between the 2 and the 0.75. The 2 is saying to you, take the second value in the data set, and that is the number 88. And I'm actually calculating Q1 here. So please follow carefully. That is 88 plus. And now you're going to work out the difference between 88 and the number after it. The number after it is 97. So 97 minus 88. And that's going to be multiplied by the remaining decimal from the calculation that you had left here. So that is 0.75. So multiply that by 0.75. And that gives you a final answer of 94.75. And that is your first quartile. So it obviously will take a bit of practice to keep getting to get that right. You'll have to keep trying it. So please look at questions like these, try them out on your own, try out even this one that you see on this worksheet, get a feel for the steps involved. As you saw here, once you knew the position 2.75, you then split that 2.75 to said take the second value in your data set, and then you will add to that your difference between that same value and the one after it, multiplied by the decimal that had been left from the position. Okay, so that's Q1. And now let's look at Q3. So Q3 here is your third quartile. So the steps are exactly the same. You need to always start off by rearranging your values in ascending order. And I'm just going to erase here. So I have some space. Okay, there we go. So here we have exactly the same first step. We have to rearrange our values in ascending order. And then once we have that, we will determine the position of your third quartile. So the position of the third quartile, we did the first step, that was to rearrange. The position of the third quartile then in step 2 is 3 multiplied by n plus 1 over 4. Because it's the third quartile, so it is 3 multiplied by 11 plus, sorry, 10 plus 1, which is 11 over 4. So that is 33 over 4, which is 8.25. So the 8.25th value in your data set is your third quartile. Now again, what this means is separate the 8 from the 0.25. 8 says go to the 8th value in your data set. So that would be here, the number 165. So you're going to say, and I'm going to start working with the calculation here. So it is Q1 equal to 165 plus, and then you have then you have the difference between the number after that, which is 183, minus that same value of 165. And this is multiplied by the decimal that was again left out of the initial calculation. So this is 0.25. And this gives you an answer of 94.75. Sorry, I just want to check if that is correct. Please give me a second. Sorry, I'm looking at the previous calculation. This is 169.5. Okay, so 169.5 is your Q3. I don't know why I'm writing Q1 here. That's why I got confused in the answers. So 165 plus 183 minus 165 times 0.25, and that gave you 169.5. So that was your third quartile, which we are now done with. So remember, the position is telling you, look at the 8th value in the data set. It was the 165. Once you have that, you will add to that the difference between the number after it, which is 183, minus that same 165, and times the decimal that remained from the position. So that gave you 169.5. Then your interquartile range in question 7 here. This is quite simple and straightforward. The interquartile range in question 7 here. This is quite simple and straightforward. The interquartile range is calculated as Q3 minus Q1. So it's simple in the sense that if you already have Q3 and Q1 calculated, all you have to do is simply work out the difference between them. Now we already had these calculated. Q1 was 94.75, and we just calculated that the third quartile was 169.5. So I'm just going to erase here. Okay, so here your interquartile range is Q3, which is 169.5, minus Q1, which we just calculated was 94.75, and that gives you a value of 74.75. So this is then your interquartile range. It's basically a measure of the spread of your data set. So here that was 94, sorry, it was 169.5 minus 94.75, which gave you the 74.75. Then you have, and I'm just going to write that next to it. So this is 74. And then your quartile deviation in the next one is no stress, no problem at all. So the next one is your quartile deviation. So your quartile deviation is calculated as your interquartile range divided by 2. So your interquartile range is what we just calculated in question 7. So it's really just about dividing that answer by 2. So your IQR is then going to be, sorry, your quartile deviation is then going to be 74.75 as your IQR divided by 2, and that's going to give you 37.38. So that is your quartile deviation. It's also just a measure of the spread of your data set, same as your interquartile range. So I'm going to write down here 37.38, so we know where that came from. And let me just erase a bit here. Okay, so that was your quartile deviation. Then the next calculation is the range. So your range is calculated pretty straightforward. It is calculated as the highest value in your data set minus the smallest value. So your highest value in your data set is 199. The smallest value is 41. So that gives you a range of 158. Also, just another measure of how spread out your data set is. Then you have your variance in the next calculation. So with your variance, there is a specific formula that needs to be followed. So the formula that needs to be followed here, and this will be in your formula sheet for your exams as well. So most of the formulas you'll find for this learning unit are in your exam paper. You'll have it in a formula sheet. So please don't stress about that. The only ones that are not in your formula sheet, and I will also be specifying this through an announcement, it will be your index numbers, which we just did in Learning Unit 2. 5 of the calculations or formula from there are not in your formula sheet. And then some of the formula from your basic probability section are not there. So I will tell you closer to your exam and also in your NSS session which values or which formula are not in your formula sheet. Okay, so back to your range, sorry, back to your variance calculation. So I'm just going to write down that your range was 158. So the formula for your variance, number 10, the formula for it is the sum of x squared minus n times your mean squared, and this is over n minus 1. So this is the calculation for your variance. That would mean that you need to have n, your sample size, here and here. You need to have your mean here, which you already did in question 1, and you need to have the sum of x squared. So to get to the sum of x squared, it's as simple as taking each individual value in your data set and squaring it. So it's basically saying 41 squared, that's the first number, plus 88 squared, plus 97 squared, plus 109 squared, and so on. So you'll do that for all of the numbers. You'll continue adding till you get to the last one, and that's going to be finally your sum of x squared. So here, the sum of x squared, we know how to calculate it, and then the mean, we said we already have it because we had calculated it in question 1. So let's substitute into this formula the sum of x, and I'm just going to write it down for you. It means that it's the 41 squared, this bit that I had written at the top. So 41 squared plus 88 squared plus 97 squared and so on. This is giving you a total of 188,059. So 188059. And then this is minus n, which is your sample size, that was 10, multiplied by your mean, which you got from question 1 here. This was 129.5 squared over n minus 1, 10 minus 1. And that gives you an answer of 2,261.83. Okay, so your variance then is your sum of x squared minus n times your mean squared over n minus 1. So 2261.83 is your variance. Then you have your standard deviation in question 11. And your standard deviation is pretty simple. It is the square root of this entire bracket. So it's the square root of the sum of the bracket. So it's the square root of the sum of x squared minus n times the mean squared over n minus 1. Sorry, let me just write that a little bit neater. Okay, so here is your variance, and then your standard, this is your variance. I'm going to write that here. The symbol we use to denote it is also this. Sorry, I already wrote that, so I'm just going to take that off. Okay, so this is the symbol for your variance. And then for your standard deviation, we either use the letters SD or we use a symbol that looks like that. So all you really have to do with your standard deviation is just find the square root of your variance, and that will be it. So here for this example, your variance was the 2261.83. Now all we need to do is find the variance of that, sorry, find the square root of that to give us your standard deviation. So let me just erase here. Okay, so here is your standard deviation. So it's a square root of your variance, 2261.83, and that gives you 47.56. So that is your standard deviation, and then you have your coefficient of variation, which is calculated as, so it's COV. This is calculated as the standard deviation over the mean multiplied by 100. So your standard deviation is what we just calculated here, 47.56. So it's 47.56 over your mean, which is in question one, right at the top here, 129.5. And that's multiplied by 100. So that gives you an answer of 36.73%. And that is your coefficient of variation. Then the next one is to construct a 5-number summary and then the respective box and whisker plot. So here you will need your answers to be listed out in ascending order, just because this is the way in which it needs to be able to identify the skewness. So what I'm going to do is, because there's only 10 values, and please pay careful attention to how your box and whisker plot is drawn up. So here you have a 5-number summary and then the respective box and whisker. A 5-number summary is done in table format. It is where you make note of the maximum, the minimum, the Q1, Q2, and Q3. So this is minimum, maximum, and then Q1, Q2, Q3. So the minimum in the data set is the lowest number, so that would be for the 41 in your data set. Then you have the maximum value in the data set, which is 199. Then we had calculated Q1 already, that was 94.75. Marker. What's wrong with the screen? Okay, so your Q1 is back to that 94.75. Sorry, the screen is just freezing a bit. So 94.75. Q2, which is your median, and I'm just going to write it on the side here so that you're aware of that. Q2 is your median, which we already determined was 134.5. And Q3 is your third quartile, which we again already calculated was 169.5. So that's your 5-number summary. And the respective box and whisker plot. So I'm going to draw it very roughly. And you can, if there are few numbers, like here there's only 10 numbers, you can just put all 10 numbers onto your data set. So onto your number line. So you have 41, 88, 97, 109, 127. It must be done in ascending order here as well. 142, 144, 165, 183, and 199. And 199. Let me just see if I can move this a little bit this way. Okay, so here's your 10 numbers. The first thing you're going to do is put a dot in at your minimum and your maximum. So here's your minimum at 41. Your maximum is 199. Then you're going to draw a line at Q1, which is 94.75, according to this 5-number summary. So 94.75, that should be somewhere here. So I'm going to just draw a line there for now. Then you have your Q3. Go with Q3 first. So that's 169.5. That should be somewhere here. And then in the center, you can, well, actually across them, you can just join that. And then at Q2, which is your median, 134.5, you're going to draw that here. And you'll join your lines to the, from the minimum, this pencil. Okay, so from the minimum to the box on this side, from the maximum to the box on this side, and that is your 5-number summary together with your box and whisker plot. So here, if you look at this, it seems to be leaning more, a little bit more towards the right. But even if you can't tell easily, you can work out the difference between Q1 and Q2. And then you can work out the difference between Q2 and Q3. Sorry, I went a bit too far here. Q2 and Q3. So the difference between Q2 and Q1. Q2 is 134.5 minus your minimum, which is 41. Sorry, not your minimum, your Q1. So the Q1 is 94.75. Q3 minus Q2, Q3 is 169.5 minus your Q2 is 134.5. So this here, you can work out the difference between them. I will work out the difference for you. So 134.5 minus 134.5 minus 94.75. That's 39.75 as the difference between these two. So 39.75. And then the difference between 169.5 and 134.5. So 169 minus 169.5. Sorry, it's 169.5 minus 134.75. Sorry, yes, 134.5, not 134.75. So 134.5. So that is 35. So the 35 would be in here. So if you look at this, and if ever you are confused about the skewness of your data set, you will look at, firstly, at first glance, look at the table and see if you're able to identify, is it skewed to the right, is it skewed to the left, and so on. If you find that it is more skewed to the right, then it's positively skewed. If it's more skewed to the left, then it's negatively skewed. And if you find that it looks like it's equal, then it is no symmetry or symmetrical distribution, no skewness or symmetrical distribution. Now, if you find that you look at it and you can't tell whether it is a symmetrical distribution or a positively skewed or negatively skewed distribution, then do the same calculation that I did. Work out the difference between Q1 and Q2, and that gave you, in this case, 39.75. And then work out the difference between Q2 and Q3, and that will give you also, like I have shown here, the block on the right, the actual value of that. And now you'll be able to determine whether it is a positively skewed, negatively skewed, or asymmetrical distribution. So, like I said, there is a general rule. You will see it in your textbook as well, where if it is wider or if there's a greater difference on the left, then it's negatively skewed. If there's a greater difference on the right, then it is positively skewed. And if it looks like it is, or if the values are essentially equal to each other, then it will be a symmetrical distribution. Okay, so this is the box and whisker plot. We're done with that. And then the last calculation for today is Pearson's coefficient of skewness. So here, sorry, I actually didn't answer. Well, there was no actual statement that you needed to give for question 13 in terms of the box and whisker plot. But because you can see that there is a larger difference on the left compared to the right. So the left, the block is 39.75, and then on the right, it is 35. That means that it's skewed to the left. You can actually literally say that, skewed to the left, or you can say that it is a negatively skewed data set. Okay, so that is your diagram, your diagrammatic explanation of the skewness of your data set. And then also, just to prove that it is negatively skewed as well, you can do the last calculation. This is Pearson's coefficient of skewness. This is calculated as 3 multiplied by the mean minus the median over your standard deviation. Now, we already calculated the mean in the first question here. So that was 129.5. Your median was 134.5. Your standard deviation in question 11 was 47.56. So it's quite easy because you have the values available to you already. So 129.5 minus the median of 134.5 over your standard deviation of 47.56. And this gives you an answer of minus 0.32. Now here, the ruling when you calculate your Pearson's coefficient of skewness is that if you get an answer, a value from Pearson's coefficient of skewness that's equal to 0, that would mean that it is a symmetrical distribution. If you find that your answer is greater than 0, then it is a positively skewed data set. And if you find that your answer is less than 0, then it is a negatively skewed data set. And if you find that your answer is less than 0, then it is a negatively skewed data set. Now, in this case, your answer was a negative. It was minus 0.32. So that would mean that because it's less than 0, it is a negatively skewed data set. So that's the same thing we said when we did this as well. Number 4 here, we said it's negatively skewed because the mean was less than the median. And then here, when we drew up the box and whisker plot just now, we also said it was negatively skewed because the left-hand side, the box was bigger on the left or skewed to the left compared to the right. And so that was negatively skewed as well. So either one of these three methods can be used to tell you about your data set and whether it's negatively or positively skewed. Okay, so that's it for today. I'm going to stop here. That's quite a bit that we've covered. It's actually all of the questions, almost all of the questions that they can ask you for Learning Unit 3 for your ungrouped data. And then I will be uploading a video for you to watch to cover the grouped data as well. Any questions? So the recordings are generally uploaded the same evening, most likely. If not, then it should be by tomorrow evening latest. Okay, so that's it for today. Thank you, everyone. I hope this was good. I hope this was useful. And I will let you know as soon as I have uploaded this or made this recording available, and then also the others as well. Please make sure to try out these examples as well. Maybe just again, try them out on your own before you look at the solutions and then get a feel for how to go about answering them, the steps involved, and so on, and then check that your answers are correct. Thank you. Enjoy the rest of your evening, and I will chat to you again soon. Cheers, everyone.